In this video, we're going to go over section 1.5, quadratic equations. So a quadratic equation is any equation that can be written in the form of ax squared plus bx plus c equals 0. The equals 0 part is why it's an equation, where a, b, and c are real numbers and a is not equal to 0. If a were 0, that would get rid of our x squared term, which would make it a linear function instead of a quadratic. So we're going to go through several different methods of solving today. And so we're going to start by solving quadratic equations by factoring. So if you need to review any factoring, you can refer back to the P.5 video. So here are some steps that we're going to be going through. So I'm not going to read them to you, but these are the steps that we're going through each time, making sure that we factor completely and everything. Okay, and you can always check your answer. So here we go. We're going to solve by factoring. So first off, notice that we have 9x squared minus 18x equals 0. Everything is set equal to 0. So then we can start factoring. There is a greatest common factor of 9x. So that means we can divide out a 9x in both terms. And so remember that our greatest common factor goes on the outside. On the inside would be what's left over. So 9x squared divided by 9x is x. Negative 18x divided by 9x is a negative 2, equal to 0. Once you get it completely factored, you can set each factor equal to 0. And only factors that have an x need to be set equal to 0. Then you can solve each individual equation. So this first equation, we would divide both sides by 9. That gives us x equals 0 because 0 divided by 9 is 0. Second equation, we can add 2 to both sides. And that would give us x equals 2. Okay, so that would be our solutions for this particular problem. Okay, now when you go to type this in on your homework, you're going to type in 0, 2, and that's all you're going to type in. Make sure no spaces between the numbers, or you can type in 2, 0, but you're just typing in those two numbers into the braces that are already given to you. Okay, looking at the next one, notice that we have things on both sides of the equal sign. So we actually want to move all of this to the other side because we want this to be a positive x squared. So we're going to start by adding x squared to both sides. And in the same step, we're going to move over that 4 by subtracting 4 from both sides. So when we do that, we get x squared minus 3x minus 4 equal to 0. And so now we can factor. To factor, we're going to, because there is just a 1 in front of the x squared, we can just take the last number, which is a negative 4, and we can place that on top. You can take the middle number, which is negative 3, and place that on bottom. And so you want to figure out what you can multiply to get the top, add to get the bottom. And that would be a negative 4 and a positive 1. And so that allows us to go straight into x minus 4 times x plus 1 equals 0. Then you can set each factor equal to 0 to solve. And so when you do that, we'll add 4 to both sides, and that will give us x equals 4. On the second one, we will subtract 1 from both sides, and that will give us x equals negative 1. So we found our two solutions, and so we're going to write them, type them in. Negative 1, 4, or 4, negative 1. It doesn't matter. Just make sure no spaces between, and you just list them with commas. Okay. It does not matter the order. You can also take these solutions and plug them back in for the x one at a time, and it should work out. So if you plug them in, the left side should equal the right side, and you would plug them in for every x. So one number first and then the second number. Okay, the next one, we see that this needs to be moved over because this is already positive. So we're going to subtract 3 from both sides. That's going to give us 2x squared plus 5x minus 3 equals 0. And now we can go ahead and factor. This time we're going to have to do an extra step because there's a number in front of the x squared. So that extra step is taking this and multiplying it times the last number. That's going to give us something that looks like this: x squared plus 5x minus 3. Oh, sorry, that should turn into a minus. 2 times negative 3 is a negative 6. Then we can factor using that same method that we did earlier. So we have the negative 6 on top, the positive 5 on bottom. What we can multiply to get a negative 6 and a positive 5 would be a 6 times a negative 1. So that would allow us to factor this into x plus 6 times x minus 1. From here, the next step would be, because of that number in front, we're going to divide both of these by 2. If they divide, then if it simplifies nice and neat, we'll simplify it. So 6 divided by 2 simplifies nice and neat to 3. But if it doesn't simplify, like 1 over 2, we're going to put that 2 in front of the x like this. And so this will be our factored form. The method that we used, so this entire method right here, is called slide and divide. Okay, so now that we've done that, we can go ahead and set each factor equal to 0, and we can solve. So the first one, we just need to subtract 3 from both sides. When we subtract 3 from both sides, we get x equals a negative 3. The second one, we're going to start by adding 1. It's going to take us 2 steps. So we get 2x equals 1. And then we're going to divide both sides by 2. And that's going to give us x equals 1/2. So we have our solutions right here, but to type them in, we're going to type in negative 3 comma 1/2, and 1/2 does need to be written as a fraction, so we have that. Okay, so that is how you solve by factoring. The next method we're going to talk about is solving using the square root property. So the square root property says that if u is an algebraic expression and d is a non-real zero, then u squared equals d has exactly 2 solutions. If u squared equals d, then u, when you take the square root of both sides, is equal to plus or minus the square root of d. So what this is basically telling us is anytime you're solving a quadratic equation by taking the square root of both sides, you're going to end up with a plus or minus symbol. Okay, so here we go. And this only works when you have an x squared term and a constant. It does not work if you have an x squared term and an x. That is when you'll need to factor or use another method. So for this particular problem, we're going to go ahead and subtract or add 49 to both sides. When we do that, we get x squared is equal to 49. Then we can take the square root. Now that the x squared is completely by itself, nothing is being added, subtracted, multiplied, or divided by it, we can take the square root of both sides. When we do that, we get x equals, because we're taking the square root, we need a plus or minus, and the square root of 49 is 7. So that would be our solution right here. What this means, plus or minus, that's our lazy way of saying that x is equal to a -7 and x is equal to a +7. So when you type this in, I believe you can use the plus or minus symbol, or you can split it up into 2 separate ones to be safe. So we would get that. The part that I'm highlighting in this bracket would be the part that you're typing in. Okay, so now we have another one. We're going to go ahead and divide both sides by 3. And that would give us x squared equals 12. Okay, now that the x squared is by itself, we can go ahead and take the square root of both sides. So that's going to give us x equals plus or minus. And now here is where we have to simplify this radical. So to simplify 12, we're going to break it down until we get all prime numbers. Prime numbers are like 2, 3, 5, 7, 11, 13. Numbers that are only divisible by 1 in itself. So when we do this, I like to start with 2 first. So 2 goes into this 6 times. And then 2 goes into that 3 times. And those are all prime numbers. So what we look for are pairs. If it has a pair, it gets to leave the radical and become a big number. If it does not have a pair, then it has to stay on the inside. Okay, so we would get 2 square root of 3 as a simplified version of our answer. Okay, and so sometimes it doesn't simplify, sometimes it simplifies, and we can go through a few more examples if we need to, but again, let's write this out. -2 rad 3 and +2 rad 3. Rad 3 is the same thing as the square root of 3. The symbol is a radical, and I just abbreviate it to rad. So some other examples you could see would be like the square root of, let's do 15. So if you try to break down the square root of 15, that would break down into 3 times 5. And notice that doesn't break down anymore. So if we had the square root of 15, it would just stay the square root of 15. But let's say we had the square root of 32. Okay, the square root of 32 breaks down into 2 times 16, 2 times 8, 2 times 4, and then 2 times 2. So you want pairs. This is a pair, it gets to leave as a big 2. This is a pair, it gets to leave as a big 2, and it gets multiplied by the other big 2. But this one is not a pair, so it stays on the outside like that. And then you multiply 2 times 2, and so this would be 4 rad 2. And that's how it would be simplified. Okay, now let's solve some more. So here we go. We have 4x squared plus 42 equals -8. So we want to get everything away from the x squared before we can square root. So we have -42 to both sides. That would give us 4x squared equal to a -50. And then we're going to divide both sides by 4. And so when we do that, we get x squared equal, I'm going to leave it as -50 over 4. And so now that x squared is by itself, we can square root both sides. When you're square rooting a fraction, you can square root the top and the bottom individually. Okay, so when we do that, we get x equals plus or minus, and we're going to get a fraction as an answer. Now, the square root of 4 in the denominator is just 2. That's pretty easy. But we need to talk about the square root of 50. So first off, when you take the square root of a negative number, you're going to get the imaginary unit I. So the square root of -1 is equal to I. That's something that we need to know. Okay, so because we're taking the square root of a -50, that is the same thing as the square root of -1 times the square root of 50, which is the square root of -1 times the square root of 50. So we're going to get the imaginary unit from here. So our answer will have the letter I. Okay, now we need to break down 50. 50 breaks down into 2 doesn't go in, 2 times 25. And then 2 doesn't go into 25, 3 doesn't go into 25, but 5 does. That would be 5 times 5. So we have a pair of 5s that get to leave, and the 2 does not have a pair, so it's going to stay on the inside. And so it breaks down into 5 rad 2. So we have 5 rad 2 divided by 2i. So when you go to type this in, I would type it in using the fraction button with the I off to the side. And so I would type in -5 rad 2 divided by 2 and then the I. And then +5 rad 2 divided by 2 and then the I. You could also type it in as -5i rad 2 divided by 2 and +5i rad 2 divided by 2. Okay, we just need to make sure that the I does not go underneath the radical, because then it will count it wrong. So either one of these would be a correct way to type this in. So I'm going to go ahead and highlight that. And then if you feel better writing it that way, that's the same thing. Again, that's the letter I. Okay, so looking at the next one. So notice now that this entire thing is being squared, but nothing's being added, subtracted, multiplied, or divided outside of that. So you can go straight into the square root. Okay, when we do this, that means that we're just going to have x plus 5 equal to plus or minus the square root of 14. Now, if this were a number that could be simplified, it would be super important to split this up and simplify it. But the square root of 14 doesn't simplify, because 14 only breaks down into 2 times 7, and that's it, which is no pairs, so it stays the same. Now, just to make a good habit of it, I'm going to keep it split up like this. So we're going to have the square root of 14, or x plus 5 equals the negative square root of 14, and x plus 5 equals the positive square root of 14. And then we're going to solve each equation individually. So we're going to subtract 5 from both sides. Oh, I forgot the 5. So we would get x equals -5 minus the square root of 14. And then over here, -5 minus 5. We would get x equals -5 plus the square root of 14. And so we have two different answers here, one with a plus, one with a minus. So we have -5 plus the square root of 14, comma, make sure that comma is not in the radical, and then -5 minus the square root of 14. It does not matter the order in which you write them in. Okay, if you wanted to put the minus first and the plus second, that's fine. Just make sure this comma does not end up underneath the radical. That is a very common mistake. So that is solving using the square root property. The last property, or the last way of solving, is using the quadratic formula. The quadratic formula works 100% of the time. So if you don't like any of the other two methods used, then definitely go the quadratic formula route. So the quadratic formula is this equation right here. -b plus or minus the square root of b squared minus 4ac, all over 2a. So it's important that you're able to identify a, b, and c from this equation right here. A is with the x squared term, b is with the x, c is with itself, the constant. Okay, now when we do this, it is important to know about the discriminant, because the discriminant tells us what kind of answer we're going to have. The discriminant is the part that's underneath the radical. Okay, that's that b squared minus 4ac. And depending if that number is negative, positive, or zero, it tells you about your solutions. So if a plus or b squared minus 4ac is greater than 0, meaning it's positive, there's going to be two different real solutions. So two different numbers like 5, 6, 1/2, -2, -3, something like that. If a b squared minus 4ac equals 0, then there's only going to be one solution, and that solution appears twice. And then lastly, if b squared minus 4ac is less than 0, then there will be two complex solutions, which is what we had in example C with the I. Okay, so we're going to solve this and using the quadratic formula. So here we go. First thing we do is we identify our A, our B, and our C. So A is equal to 1, B is equal to 8, C is equal to 12. I like to start with the discriminant, so that's b squared minus 4ac. That would be 8 squared minus 4 times 1 times 12. Okay, and so that would be, let's see, 64 minus 48. And that would equal 16. Because this number is greater than 0, that means we're going to have two real solutions. Okay, because 16 is greater than 0, we're going to have two real solutions. So now we can go into the quadratic formula. That would be x equals negative b plus or minus the square root of 16, since we already simplified that, all over 2 times 1. That would be equal to negative 8 plus or minus 4 over 2. So we can split this into two separate equations. We have x equals negative 8 plus 4 over 2. And x equals negative 8 minus 4 over 2. Negative 8 plus 4 is a negative 4 over 2. And negative 4 over 2 is negative 2. We would have on the second one, negative 8 minus 4, that's a negative 12 over 2. And that would be a negative 6. So our two solutions for this would be negative 2 and negative 6. Okay, so looking at the next one, before you're able to solve it, it does need to be set equal to 0. So we would need to actually subtract 3 from both sides first. And so we would be dealing with 2x squared plus 6x minus 3 equals 0. Okay, so from here, our A is 2, our B is 6, and our C is negative 3. So to follow our formula, B squared minus 4AC, that would be 6 squared minus 4 times 2 times negative 3. 6 squared is 36. 2 times 4 is 8 times 3. Negative 3 is a negative 24. If we add these, because two negatives make a positive, that would be equal to 60, which is greater than 0. So we're going to have 2 real solutions. Okay, so now we can get into the quadratic formula. So that would be x equals negative b plus or minus the square root of 60 all over 2 times a, which is 2. So that would be equal to negative 6 plus or minus. We do need to simplify that square root, times 4. So 60 breaks down into 2 times 30. That breaks down into 2 times 15. And that breaks down into 3 times 5. So we have a pair of 2's that get to leave. And then neither one of these have a pair. So you multiply them back together to get 15. And that's what goes underneath the square root, the radical. So we get 2 rad 15. Okay, and so let's go ahead and split this up. Negative 6 plus or minus 2 rad 15 divided by 4. Oh, I didn't split it up after I said I was splitting it up. So let's do the plus version first. And then we have negative 6 minus 2 rad 15 all divided by 4. We can go ahead and simplify anything that's not in the radical. So that means we can simplify the 6, the 2, and the 4 if they all have a number in common. Same thing with this one, if they all, and all 3 of those are divisible by 2. So we get negative 3 plus 1 rad 15 is just rad 15 divided by 2. And then same thing over here, negative 3 minus rad 15 over 2. And so that would be our final answer right here. So I hope this video helps. And then the last part is, if you're not told, basically you can pick how you want to solve. I would always start with factoring because I think that's quickest and easiest. But then the quadratic formula works 100% of the time. So maybe that would be the method you would choose. So if you have any questions, please make sure you email me so I can help you out.